We're told that x plus 1 is a factor of the cubic expression 2x cubed plus kx squared minus 10x minus 3k, and we've been asked to find the value of k. So if x plus 1 is a factor, then x equals minus 1 is a solution or a root to the cubic equation 2x cubed plus kx squared minus 10x minus 3k equals 0. So subbing in minus 1, I have 2 by minus 1 cubed plus k by minus 1 squared minus 10 by minus 1 minus 3k equals 0. Minus 1 cubed is minus 1 by 2 is minus 2. Minus 1 squared is plus 1 times k is plus k. Minus 10 by minus 1 is plus 10. And then we have minus 3k equals 0. So I have k minus 3k is equal to, we'll add a 2 to both sides to give us 2 on the right, and subtract a 10 from both sides to give us minus 10 on the right. K minus 3k is minus 2k is equal to 2 minus 10 is minus 8, and then I'll divide both sides by minus 2 to give me that k is equal to 4. So we've solved for k, and what we're going to do now is we're going to sub that value of k back into the cubic expression. So we have 2x cubed plus kx squared, which is plus 4x squared, minus 10x, and then minus 3k, which is minus 3 times 4, which is minus 12. And we've been asked to find the two other factors of this cubic expression. We can do that by doing long division with x plus 1 and the cubic expression 2x cubed plus 4x squared minus 10x minus 12. So dividing x into 2x cubed, we get 2x squared. We're going to multiply 2x squared by x to give us 2x cubed, and 2x squared by 1 to give us 2x squared. We draw a line underneath, and we're going to subtract the second line from the first line by changing both the signs. 2x cubed minus 2x cubed is 0. 4x squared minus 2x squared is 2x squared, and then we'll bring down the 10x and the minus 12. X into 2x squared goes 2x times. 2x by x is 2x squared. 2x by 1 is plus 2x. Again, we'll draw a line underneath and subtract the bottom line from the top line by changing both the signs. First two terms cancel. We then have minus 10x minus 2x, which is minus 12x, and then we bring down the minus 12. X into minus 12x is minus 12. We're going to multiply minus 12 by x to give us minus 12x, minus 12 by 1 to give us minus 12. Draw a line underneath, subtract the bottom line from the top line by changing both the signs, and both terms will cancel this time to give us a remainder of 0, which confirmed that x plus 1 was a factor as it divided in evenly. And then to find the two other factors, we are going to factorize the quadratic expression, which was the other factor up here on top. So we have two sets of brackets. We have 2x and x. We have 4 and 3. And then just to determine the signs, the product of the inner terms is 4x and the product of the outer terms is 6x. And I need these to sum to give me 2x, so I need to have minus 4 plus 6. So minus and a plus like that. And so the other two factors of that cubic expression are 2x minus 4 and x plus 3. Just a quick note on the factorization of 2x squared plus 2x minus 12. You'll note that a common factor to all of the terms here is 2. And so sometimes when there is a common factor like this, it results in two possible factorizations. So we've already done the factorization where we had 2x and x, and then we decided to use 4 and 3, and we had a minus and a plus. And this works. We can see that minus 4x plus 6x does give us 2x. But equally, we could have set up two sets of brackets. And if we multiply this second bracket by 2 to give us 2x plus 6 and divide the first bracket by 2 to give us x minus 2, we'll see that this is also a factorization. The inner terms give us minus 4x and the outer terms give us 6x, and again minus 4x plus 6x gives us the plus 2x. Now note that this won't have any effect on solving the equation where this quadratic is equal to 0. If we let this equal to 0, we can see that x minus 2 would be 0 and 2x plus 6 would be 0. X is equal to 2, 2x equals minus 6, x equals minus 3. So those would be the roots. We weren't asked for those in this question, but that's how we would do it. But likewise, if I took the first factorization and let that equal to 0, we have 2x minus 4 equals 0, x plus 3 equals 0, 2x equals 4, x equals 2, and x equals minus 3. So we would have got the same two roots or solutions regardless of which factorization we used. But most of the time when we're factorizing a quadratic, there's only one solution. But sometimes, like I said, if there's a common factor, that common factor could have been applied to either bracket to give us two separate sets of factorization.